What is CI/CD in DevOps?
CI/CD stands for Continuous Integration and Continuous Delivery/Deployment. Two foundational practices in DevOps that automate the path from code commit to production. Continuous integration, CI, means developers frequently merge their code changes into a shared repository, often multiple times per day. Each merge triggers an automated build and test cycle, catching integration bugs early before they compound into bigger problems. Continuous delivery, CD, extends CI by automatically preparing code for release to production. Every change that passes the test suite is deployable, but a human still makes the final decision to push to production. Continuous deployment goes one step further. Every change that passes all pipeline stages is automatically deployed to production with no manual intervention. This requires a very high level of test confidence. The key distinction: delivery means always ready to deploy, while deployment means always deploying.
What are the benefits of using CI/CD?
Faster release cycles, automation removes manual bottlenecks. Teams can ship multiple times a day instead of once a quarter. Early bug detection, running tests on every commit means defects are caught within minutes of being introduced, when the context is still fresh and fixes are cheap. Reduced integration risk. Frequent merges keep branches short-lived, which dramatically reduces merge conflicts and integration hell. Consistent, repeatable deployments, automated pipelines eliminate human error in builds and releases. The same artifact that was tested is the one that gets deployed. Faster feedback loops. Developers get immediate feedback on code quality, test results, and deployment status, enabling rapid iteration. Improved team confidence. When you know every change is automatically tested and safely deployable, teams are more willing to make improvements and ship frequently.
What are some popular CI/CD tools?
Open source/self-hosted. Jenkins, the most widely used open source CI/CD server. Extremely customizable with 1,800 plus plugins, but requires significant maintenance overhead. GitHub Actions/drone lightweight alternatives with YAML-based pipelines, platform integrated. GitHub Actions, deeply integrated with GitHub, uses reusable workflow files in
GitHub/workflows/.
GitLab CI/CD, built directly into GitLab, configured via
GitLab CI.
with strong container-native support, Bitbucket pipelines, integrated with Atlassian's ecosystem, cloud-native. AWS Code Pipeline plus Code Build, native AWS CI/CD, integrates with other AWS services. Azure DevOps Pipelines, Microsoft's offering, supports any language and cloud. Google Cloud Build, serverless CI/CD on GCP, cloud-based SaaS. Circle CI, fast, Docker-first CI/CD with strong caching and parallelism. Travis CI, one of the earliest cloud CI services, popular in open source. The right choice depends on your source control platform, cloud provider, and team size.
What is a CI pipeline?
A CI pipeline is an automated sequence of steps that validates every code change before it can be merged or deployed. It acts as a quality gate, ensuring that broken code never reaches shared branches or production. Typical CI pipeline stages. 1. Source. A developer pushes code or opens a pull request, triggering the pipeline. 2. Build. The application is compiled or bundled, for example.
MVN package. NPM run build. Docker build.
3. Test. Automated tests run. Unit tests, integration tests, linting, and static analysis. 4. Security scan. SIST tools check for vulnerabilities in code and dependencies. 5. Artifact creation. If all checks pass, a deployable artifact is produced, Docker image, JIR binary, and stored in a registry, example GitHub Actions CI pipeline.
Code on push pull request jobs CI runs on Ubuntu latest steps uses action/checkout at v4 run npm CI run npm runlint run npm test run npm run build.
The goal is fast feedback. A good CI pipeline completes in under 10 minutes so developers aren't blocked.
What is a build artifact in CI/CD?
A build artifact is the output of the build process, a compiled, packaged, and versioned unit of software ready for deployment. Examples by ecosystem: Java, JIR, WIR, or EIR files. JavaScript/Node bundled.
Dist/.
Directory npm packages, containers Docker images pushed to a registry, for example.
My app v1.2.3.
Go/Rust, compiled binaries, infrastructure, Terraform plan files, cloud formation templates. Why artifacts matter in CI/CD. Build once, deploy many, the same artifact is promoted through staging. Production, ensuring what you tested is exactly what you deploy. Traceability, each artifact is tied to a specific commit, branch, and build number. Rollback, previous artifacts are stored in registries, Nexus, Artifactory, ECR, GHCR. So you can redeploy an older version instantly. A critical principle: never rebuild between environments. Promote the same immutable artifact through each stage.
How does source control work in CI/CD?
Source control, typically Git, is the foundation that CI/CD pipelines build upon. Every pipeline starts with a change in the repository, how they integrate. Developers push code to a remote repository, GitHub, GitLab, Bitbucket. Webhooks notify the CI/CD system of the change. The CI/CD tool checks out the specific commit and runs the pipeline. Results, pass/fail, are reported back as commit statuses or check runs visible in the PR. Branching strategies that shape CI/CD. Trunk-based development, short-lived branches, frequent merges to main, CI runs on every push. Git flow, separate develop/release/hotfix branches, each with different pipeline behavior. GitHub flow, feature branches plus pull requests, CI gates before merge. Branch protection rules enforce CI/CD quality gates, for example, requiring all status checks to pass before a PR can be merged. This makes source control and CI/CD inseparable.
What is the purpose of unit tests in CI/CD?
Unit tests validate individual functions or components in isolation and are the first line of defense in any CI pipeline. They run fast, milliseconds each, and catch regressions immediately. Why they're critical in CI/CD? They execute in seconds, providing instant feedback to developers. They're deterministic. No network calls, no databases, no flaky behavior. They form the base of the testing pyramid. Many unit tests, fewer integration tests, even fewer E2E tests, common unit testing frameworks, Python, Pytest, Unitest. JavaScript, Jest, Vitest, Mocha, Java, JUnit, TestNG, Go, built-in.
Testing.
Package example, Python with Pytest.
Code def calculate discount price percentage return price asterisk 1%/100 def test calculate discount assert calculate discount 120 equals 80.0 assert calculate discount 50 equals 50.0.
In CI/CD, unit tests typically run as the first test stage. If they fail, the pipeline stops immediately without wasting time on slower integration or E2E tests.
What is versioning in CI/CD?
Versioning assigns meaningful identifiers to each release, enabling tracking, rollback, and communication about what changed. Semantic versioning, SEMVer, is the most common scheme.
MIJORMINOR patch.
MIJOR 2.0.0. breaking changes, incompatible IPI modifications, MINOR 1.3.0. New features, backward compatible. Patch 1.3.2, bug fixes, backward compatible, how CI/CD uses versions. Git tags trigger release pipelines, for example, pushing.
v1.2.0.
Deploys to production. Artifact tagging, Docker images, binaries, and packages are tagged with version numbers, pre-release versions.
1.2.0 RC.1.
Or,
1.2.0 beta.3.
for staging/QI environments, automated versioning strategies, commit hash-based.
v1.2.0 ABC 1234.
For unique identification, build number-based.
v1.2.0 plus build.456.
For CI traceability, conventional commits tools like
Semantic release.
auto-bump versions based on commit messages.
Vital.
Is minor.
Vexel.
A patch.
BREIKINGCHINGE.
Major. Good versioning makes rollbacks trivial and changelogs automatic.
What is a rollback in CI/CD?
A rollback is the process of reverting to a previously known good version when a new deployment introduces bugs or failures. It's your safety net. Rollback strategies. 1. Artifact-based rollback, fastest. Redeploy the previous artifact from your registry, no rebuild needed.
Code cube control set image deployment /myapp app equals myapp v1.2.2.
2. Kubernetes rollout undo. Kubernetes tracks revision history automatically.
Code cube control rollout undo deployment /myapp cube control rollout status deployment /myapp.
3. Git revert. Create a new commit that undoes the problematic changes, then let the pipeline redeploy.
Code git revert head git push origin main.
4. Feature flags. Disable the broken feature instantly without any deployment at all. Best practices. Always keep at least 3 to 5 previous artifacts in your registry. Automate rollback triggers based on health checks and error rate thresholds. Test your rollback procedure regularly. A rollback that's never been tested is a rollback that might not work.
What is a canary deployment?
A canary deployment is a risk reduction strategy that rolls out changes to a small subset of users before exposing them to everyone. The name comes from canary in a coal mine. How it works. 1. Deploy the new version alongside the current one. 2. Route a small percentage of traffic, for example, 5 to 10%, to the new version. 3. Monitor key metrics, error rates, latency, CPU/memory usage. 4. If metrics are healthy, gradually increase traffic 25%, 50%, 100%. 5. If something goes wrong, route all traffic back to the old version. Example with Kubernetes and Istio.
Code API version, networking Istio /v1 beta 1 kind, virtual service spec, HTTP, route, destination, host myapp, subset stable. Wait 90 destination, host myapp, subset canary, wait 10.
Canary versus blue-green. Blue-green switches all traffic at once. Canary gradually shifts it. Canary gives you more granular control and earlier detection of issues in production.
What is the difference between GitHub Actions and GitLab CI/CD?
Both are powerful CI/CD platforms integrated with their respective source control systems. Key differences: integration and ecosystem. GitHub Actions, tightly coupled with GitHub. Massive marketplace of 15,000 plus community-maintained actions. GitLab CI/CD, built into GitLab as part of a complete DevOps platform. Issue tracking, container registry, monitoring all included. Configuration, GitHub Actions.
GitHub /workflows **iml.
Multiple workflow files. GitLab CI/CD single.
GitLab CI.iml.
File can use.
Include.
For modularity, Runners, GitHub Actions, GitHub-hosted runners, Linux, Mac OS, Windows, plus self-hosted runners. GitLab CI/CD, GitLab shared runners plus self-managed GitLab runners with auto-scaling support. Container support, GitHub Actions, Docker container actions and service containers. GitLab CI/CD, stronger native container support with built-in container registry and auto DevOps. Unique strengths. GitHub Actions, matrix builds, reusable workflows, easy open source CI, free for public repos. GitLab CI/CD, built-in SIST/DIST security scanning, environments with review apps, parent-child and multi-project pipelines. Choose based on where your code lives and what DevOps features you need beyond CI/CD.
How do you trigger a Jenkins pipeline?
Jenkins supports multiple trigger mechanisms. 1. Webhook triggers, most common. A Git push or PR event sends an HTTP post to Jenkins, starting the build immediately.
Code triggers GitHub push.
2. Poll SCM. Jenkins periodically checks the repository for changes, less efficient than webhooks.
Code triggers poll SCM H/5 / check every 5 minutes.
3. Cron schedule. Run pipelines at specific times, for example, nightly builds.
Code triggers cron H2 * run at ~2 im daily.
4. Manual trigger. Click Build Now in the Jenkins UI or use the CLI.
Jenkins CLI build my pipeline.
5. Upstream triggers. Start a pipeline when another pipeline completes.
Code triggers upstream projects, build lib threshold, Hudson model result SUCCESS.
6. IPI trigger. Trigger remotely via REST IPI, useful for integrating with external tools like Slack bots or monitoring systems.
What is a deployment strategy?
A deployment strategy defines how new code is released to production while minimizing risk and downtime. Choosing the right strategy depends on your tolerance for risk, infrastructure, and rollback needs. Rolling deployment gradually replaces old instances with new ones, a few at a time. At any point, both old and new versions coexist. This is the default strategy in Kubernetes. Pros: zero downtime, no extra infrastructure needed. Cons: both versions run simultaneously, can cause issues if they are incompatible. Blue-green deployment. Two identical environments exist: blue, current, and green, new. Traffic is switched from blue to green all at once. Pros: instant rollback by switching back to blue. Cons: requires double the infrastructure. Canary deployment routes a small percentage of traffic to the new version first, gradually increasing if metrics look good. Pros: minimal blast radius, real production validation. Cons: more complex routing and monitoring setup. Recreate, big bang. Stops the old version entirely, then starts the new one. Pros: simplest approach, no version compatibility issues. Cons: causes downtime, only acceptable for non-critical systems. A /B testing deployment. Routes traffic based on user attributes, location, device, account type, for comparing feature variants with real users.
How do you secure CI/CD pipelines?
CI/CD pipelines are high-value targets. They have access to production credentials, cloud infrastructure, and code signing keys. Securing them is critical. Secrets management. Never store secrets in code or pipeline files. Use dedicated vaults. HashiCorp Vault, AWS Secrets Manager, Azure Key Vault. Use platform-native secrets. GitHub secrets, GitLab CI/CD variables, masked plus protected. Rotate secrets regularly and audit access control. Implement RBAC, role-based access control. Not everyone should be able to trigger production deploys. Require branch protection and PR approvals before merging. Use OIDC for cloud authentication instead of long-lived credentials. Pipeline security. Pin dependencies and actions to specific versions or SHA hashes, not.
At latest.
Run SIST, Sonar Quebec Semgrep, and dependency scanning, SNIKE Dependabot. In the pipeline, sign artifacts and verify signatures before deployment. Use minimal, hardened base images for build containers. Supply chain security. Verify third-party actions/plugins before using them. Use Salsa framework for build provenance. Implement least privilege. Pipeline service accounts should only have permissions they need. Monitoring and auditing. Log all pipeline executions and configuration changes. Alert on unusual activity. Deployments outside business hours. Unauthorized access attempts.
How do you integrate CI/CD with infrastructure as code, IIC?
Integrating CI/CD with IIC means infrastructure changes go through the same review, testing, and automation process as application code. Core principles. Store all IIC scripts, Terraform, Pulumi, CloudFormation, Ansible. In version control, infrastructure changes require pull requests and code review. Automated validation runs before any changes are applied. Typical IIC pipeline stages. 1. Lint.
Terraform FMT check. Ansible lint.
2. Validate.
Terraform validate. CFN lint.
3. Plan.
Terraform plan.
Shows what will change without applying. 4. Manual approval. Review the plan before applying to production. 5. Apply.
Terraform apply.
Only after approval. Example GitHub Actions pipeline for Terraform.
Code jobs Terraform runs on Ubuntu latest steps. Uses action/checkout at v4. Uses HashiCorp/setup Terraform at v3. Run Terraform init. Run Terraform FMT check. Run Terraform validate. Run Terraform plan out equals TF plan. Run Terraform apply TF plan. If GitHub ref equals ref/head/main.
Best practices. Use remote state with locking, S3 plus DynamoDB, Terraform Cloud. Separate pipelines for
Plan.
on PR and
Apply.
on merge to main. Use drift detection to catch manual changes to infrastructure.
What is a pipeline as code?
Pipeline as code means defining your entire CI/CD workflow in version-controlled configuration files rather than configuring it through a UI. Why it matters. Version history, you can see who changed the pipeline, when, and why. Code review, pipeline changes go through the same PR process as application code. Reproducibility, any team member can recreate the exact same pipeline. Portability, pipelines are documented and transferable. Examples by tool. Jenkins file Groovy.
Code pipeline agent any stages or stage build or steps shmvn package or stage test. Steps shmvn test stage deploy or when branch main or steps sh/deploy sh or
GitHub Actions, GitHub/workflows/SciML.
code on push jobs build runs on Ubuntu latest steps. Uses action/checkout at v4. Run npm sci and npm test.
GitLab CI, GitLab SciML.
Code stages build test deploy build script mvn package test script mvn test deploy script /deploy sh only.
This approach is sometimes called GitOps when applied to infrastructure and deployments. The Git repository becomes the single source of truth.
What is an ephemeral build environment in CI/CD?
An ephemeral build environment is a temporary, disposable environment that is created fresh for each CI/CD job and destroyed after it completes. How it works. 1. A CI job starts. A fresh container or VM is provisioned. 2. The build/test runs in a clean, isolated environment. 3. Once the job finishes, pass or fail, the environment is destroyed. Where it's used, GitHub Actions. Each job runs in a fresh VM or container. GitLab CI/CD, runners spin up Docker containers per job. Jenkins Kubernetes plugin creates pods for each build, then deletes them. A WS code build. Each build runs in a new container. Benefits: clean state, no leftover files, caches, or config from previous builds that could cause flaky results. Isolation, builds can't interfere with each other. Security, secrets and credentials don't persist after the job. Cost efficiency, pay only for compute time actually used, especially with spot/preemptible instances. Trade-off, since environments start clean each time, you need to cache dependencies, NPM packages, Docker layers, Maven artifacts, to avoid re-downloading everything on every build.
What is the purpose of a staging environment in CI/CD?
A staging environment is a production replica environment used for final validation before deploying to production. It's the last checkpoint, why it's essential. Catches issues that only appear in production-like conditions. Real databases, real network topologies, real resource constraints, enables performance testing under realistic load. Allows manual QI and UIT, user acceptance testing. For features that need human review, tests infrastructure changes, Terraform Helm charts. Safely. Typical CI/CD promotion flow.
Code dev QI/integration, staging, production.
What makes a good staging environment? Mirrors production, same OS, runtime versions, resource limits, and service mesh configuration. Uses realistic data, anonymized production data, or representative synthetic data, has separate secrets, never shares credentials with production. Is reset regularly, prevents state drift from accumulated test data. Common pitfall: if staging diverges from production, different instance sizes, different configs, stale data, it gives false confidence. Treat staging infrastructure as code, identical to production minus scale.
How does a monorepo impact CI/CD pipelines?
A monorepo stores multiple projects or services in a single repository. This has significant implications for CI/CD design. Challenges: build times explode. A naive pipeline rebuilds and tests everything on every commit, even if only one service changed. Flaky tests multiply. One service's flaky test blocks deployments for all services. Complex ownership, multiple teams push to the same repo, making access control harder. Solutions: 1. Path-based filtering, only trigger pipelines for changed paths.
Code #GitHub Actions on push paths services/API/lib/shared/.
2. Build tools with dependency graphs. Bazel only rebuilds targets affected by the change. NX computes affected projects using a dependency graph. Turborpo caches and orchestrates builds for JS/TS monorepos. 3. Affected-only testing, run tests only for packages that depend on changed code, dramatically reducing pipeline time. Monorepo advantages for CI/CD. Atomic changes across multiple services in a single commit. Shared CI/CD configuration and tooling. Easier to enforce consistent standards and linting rules. Companies like Google, Meta, and Microsoft use monorepos at massive scale with specialized build systems.
What are pipeline triggers, and how are they used?
Pipeline triggers are events that automatically start a CI/CD workflow. Choosing the right triggers ensures pipelines run when needed without unnecessary executions. Common trigger types. Push triggers run on every code push.
Code #GitHub Actions on push branches main develop.
Pull request triggers run tests before code is merged.
Code on pull request branches main.
Schedule cron triggers run at specific times, for example, nightly security scans.
Code on schedule cron 02**2 IMUTC daily.
Tag triggers run release pipelines when a version tag is pushed.
Code on push tags v asterisk.
Manual triggers, on-demand via UI or IPI.
Code on workflow dispatch, inputs, environment, type, choice, options, staging, production.
Upstream/dependency triggers, start when another pipeline completes, useful for deploy after build patterns. Best practice, use push triggers for CI, tag triggers for releases, and schedule triggers for slow tasks like security scans and dependency updates.
What is artifact versioning in CI/CD?
Artifact versioning assigns unique, traceable identifiers to every build output, so you always know exactly what code is running in each environment. Common versioning schemes. Semantic version plus build metadata.
Code myapp 1.2.3 hash release myapp 1.2.3 rc.1 hash release candidate myapp 1.2.3 plus build.456 hash includes build number.
Commit SHA-based for continuous deployment.
Code docker build t myapp $git rev parse short head docker tag myapp abc 1234 myapp latest.
Calendar-based for scheduled releases.
Code myapp 2024.0 3.15 hash date based myapp 2024.0 3.15.2 hash second build that day.
Best practices, tag immutably once.
v1.2.3
Is published, never override it with a different build. Avoid.
latest.
In production, it's ambiguous and makes rollbacks unreliable. Include provenance. Link artifacts to the exact commit, branch, and pipeline run that produce them. Use a registry. Store versioned artifacts in Nexus, Artifactory, ECR, or GHCR with retention policies. Proper artifact versioning makes rollbacks a one-line command and auditing straightforward.
How do you handle environment variables in CI/CD?
Environment variables configure pipeline behavior and provide runtime configuration without hard-coding values in source code. Types of variables in CI/CD. 1. Pipeline variables control build behavior.
Code env node env production CI true.
2. Secrets, sensitive values stored securely by the platform.
Code env ditibisEURL $secrets ditibisEURL IPIKEY $secrets IPIKEY.
3. Dynamic variables computed during the pipeline.
Code run echo SHA equals $git rev parse short head $GitHub env run echo deploying $env SHA.
Best practices, never hardcode secrets. Use platform secrets, GitHub secrets, GitLab CI/CD variables, or external vaults. Never log secrets. Most CI platforms automatically mask secret values in logs, but be careful with debug output. Use environment scoping, different values for staging versus production. GitHub Actions supports per environment secrets. Use.
Env example.
Files document required variables without including actual values. Prefer OIDC over storing cloud credentials as secrets. It's more secure and doesn't require rotation.
What is a multi-branch pipeline in CI/CD?
A multi-branch pipeline automatically creates separate pipeline instances for each branch in your repository, each potentially with different behavior. Why it's useful. Feature branches run tests and linting, the
Develop.
branch deploys to staging, the
Main.
branch deploys to production. Release branches run full regression suites. Jenkins multi-branch example.
Code pipeline agent any stages stage test steps sh npm test stage deploy to staging. When branch develop steps sh/deploy sh staging stage deploy to production when branch main steps sh/deploy sh production.
GitHub Actions equivalent.
Code on push branches main develop feature /jobs deploy if GitHub ref == ref /head/main hash production deployment steps.
Key benefit: developers get CI feedback on their feature branches without risking production. Jenkins multi-branch pipeline plugin even auto-discovers new branches and creates jobs for them.
How do you automate rollback in CI/CD?
Automated rollback detects failures after deployment and reverts to the last known good state without human intervention. Strategy 1: health check-based rollback. Monitor the deployment, and if health checks fail within a window, roll back automatically.
Code #Kubernetes automatic rollback on failed readiness probes. Spec, strategy, rolling update. Max unavailable, 0. Max surge, 1. Min ready seconds, 30. Progress deadline seconds, 120 rollback if not ready in 2 min.
Strategy 2: metric-based rollback. Use tools like Argo rollouts or Flagger to monitor error rates and latency, automatically rolling back if thresholds are exceeded.
Code #Argo rollouts analysis metrics, name, error rate, success condition, result 0.05, provider, Prometheus. Query rate HTTP pairs 5M, /rate HTTP requests 5M.
Strategy 3: Git revert automation. A failing post-deployment test triggers an automatic.
Git revert.
And redeploy. Strategy 4: feature flags. Disable the problematic feature via launch darkly, unleash, or flagsmith. No deployment needed at all. Best practices: define clear rollback criteria before deploying, error rate 1%, latency 500 ms, etc. Always run smoke tests immediately after deployment. Ensure database migrations are backward compatible, so rollbacks don't break the schema.
What is test-driven development, TDD, and how does it integrate with CI/CD?
TDD is a development methodology where you write tests before writing the implementation code, following a strict cycle. 1. Red, write a failing test that defines the desired behavior. 2. Green, write the minimum code to make the test pass. 3. Refactor, clean up the code while keeping tests green. How TDD integrates with CI/CD. The CI pipeline enforces the test suite. Code cannot be merged if tests fail. Code coverage gates ensure tests exist for new code. For example, require 80% coverage. PR checks run the full test suite on every push, giving immediate feedback. Example TDD cycle Python.
Code #step 1 red, write the test first, def test calculate attacks. Assert calculate tax 100 rate equals 0.2 equals 20.0. Assert calculate tax 0 rate equals 0.2 equals 0.0. #step 2 green, write minimal implementation, def calculate tax amount rate, return amount asterisk rate.
CI/CD enforcement.
Code steps run, PyTest cov equals src cov fail under equals 80.
Benefits in CI/CD context. Higher test coverage means more confidence in automated deployments. Fewer production bugs means fewer emergency rollbacks. Tests serve as living documentation of expected behavior.
How do you handle dependencies in a CI/CD pipeline?
Dependency management ensures builds are reproducible, fast, and secure regardless of when or where they run. 1. Lock files for reproducibility. Lock files pin exact dependency versions, so every build uses identical packages.
Package lock JSON.
/
Yarn lock.
Node.js.
Pip file lock.
/
Poetry lock.
Python.
Go sum.
Go.
Cargo lock.
Rust, use deterministic install commands.
npm sci.
Not.
npm install. Pip install require hashes.
2. Caching for speed. Cache downloaded dependencies between pipeline runs.
Code uses action/cache at v4 with path / npm key node $files / package lock JSON restore keys node.
3. Dependency scanning for security. Automatically detect vulnerabilities in third-party packages. Dependabot/renovate, automated p-articles for outdated/vulnerable dependencies. Snike/npm audit, scan for known CVEs in the dependency tree. 4. Private registries. For internal packages, use private npm registries, PyPI servers, or Artifactory to avoid dependency confusion attacks. Best practices: commit lock files to Git. Update dependencies regularly, weekly Dependabot p-articles. Fail the pipeline if critical vulnerabilities are detected.
What is containerized CI/CD?
Containerized CI/CD runs every build step inside Docker containers, ensuring consistency between local development, CI, and production environments. Why it matters. Works on my machine is eliminated. The build runs in the same container image everywhere. Dependency isolation. Each job has its own environment. No conflicts between projects. Reproducibility. Pin the container image version, and builds are identical months later. Example, GitHub Actions.
Code jobs test runs on Ubuntu latest container image node 20 Alpine steps uses action/checkout at v4 run npm sci run npm test.
Example, GitLab CI/CD.
Code test image Python 3.12 slim script pip install r requirements dxd pytest.
Service containers let you spin up databases and other services alongside your build.
Code services Postgres image Postgres 16 env Postgres password test.
Advanced pattern Docker and Docker DIND. Build Docker images inside a containerized CI job, used when the CI job itself needs to run.
Docker builds.
Containerized CI/CD is now the standard approach. Virtually every modern CI platform runs jobs in containers by default.
How do you optimize CI/CD pipelines for speed?
Slow pipelines kill developer productivity. Every minute of CI wait time is a context switch. Here are proven optimization strategies. 1. Parallelize everything possible. Run independent jobs concurrently instead of sequentially.
Code jobs lint runs on Ubuntu latest steps test runs on Ubuntu latest steps build runs on Ubuntu latest steps.
2. Cache aggressively, cache dependencies, build outputs, and Docker layers. A warm cache can cut 2 to 5 minutes off every build. 3. Use lightweight base images,
Node 20 Alpine,
50 MB, instead of
Node 20.
350 MB. Smaller images equals faster pull times. 4. Only test what changed. Use tools like NX, Bazel, or path-based filters to skip unaffected services in monorepos. 5. Split test suites. Run unit tests first, fast, catch most issues, then integration tests, then E2E tests. Fail fast. 6. Use larger runners, GitHub Actions,
Ubuntu latest XL.
or self-hosted runners with more CPU/RIM for compute-heavy builds. 7. Avoid redundant work. Don't install dev dependencies for production builds. Use multi-stage Docker builds to avoid shipping build tools. Skip steps on irrelevant branches. Don't deploy on feature branches. Target: most CI pipelines should complete in under 10 minutes. If yours takes longer, profile each step and optimize the slowest ones.
What is an approval stage in CI/CD pipelines?
An approval stage is a manual gate in the pipeline that pauses execution until an authorized person reviews and approves the deployment. It's the human checkpoint in an otherwise automated process. When to use approvals: before deploying to production, most common; before applying infrastructure changes, Terraform apply; before releasing to external customers. For compliance requirements, SOX, HIPAI, PCIDSS. GitLab CI/CD.
Code deploy production stage deploy script / deploy sh production when manual environment name production.
GitHub Actions with environments.
Code deploy runs on Ubuntu latest environment. Name production hash requires reviewers configured in repo settings. Steps run/deploy sh.
Jenkins.
Code stage approve. Steps input message deploy to production. Submitter admin release team.
Best practices. Limit approvers to specific teams or roles. Set timeout periods. Auto-reject if not approved within n hours. Show the approver what's changing. Diff, changelog, test results. Log who approved what and when for audit trails.
What is handling secrets in CI/CD pipelines?
Secrets, API keys, database passwords, tokens, certificates. Require special handling in CI/CD because pipelines are automated and often run on shared infrastructure. Platform-native secrets, GitHub Actions, repository or environment secrets.
$secrets my secret.
A GitLab CI/CD. CI/CD variables, masked plus protected plus scope to environments. Jenkins, credentials plugin with credential binding. External secret managers, recommended for production. HashiCorp Vault, dynamic secrets, automatic rotation, fine-grained policies, a WS Secrets Manager /SSM parameter store. Azure Key Vault, Google Secret Manager. Example, GitHub Actions with secrets.
Code jobs deploy runs on Ubuntu latest. Steps name deploy env ditibISEURL $secrets ditibISEURL IWSICCESSKEYID $secrets IWSICCESSKEYID run/deploy sh.
Security rules, never commit secrets to Git use.
Git ignore.
Pre-commit hooks and tools like
Git secret.
never echo or log secret values. Rotate secrets regularly and after any suspected exposure. Scope secrets to specific environments. Staging secrets not equal to production secrets. Prefer OIDC over static credentials for cloud provider authentication. No secrets to store at all. Audit secret access. Know who accessed what and when.
What are self-hosted runners in CI/CD?
Self-hosted runners are machines you manage that execute CI/CD jobs as an alternative to the cloud-hosted runners provided by your CI platform. Why use self-hosted runners? Performance, dedicated hardware with more CPU, RAM, or GPU than cloud-hosted options. Cost, for high-volume pipelines, self-hosted can be significantly cheaper than per-minute cloud pricing. Network access. Jobs can reach internal services, private registries, or on-premise databases without exposing them to the internet. Compliance. Some industries require builds to run on controlled infrastructure. Specialized hardware, GPU builds, IRM compilation, iOS builds require Mac OS. How to set up GitHub Actions. 1. Register a runner. Settings, Actions, Runners, New self-hosted runner. 2. Install the runner agent on your machine. 3. Reference it in workflows.
Code jobs build runs on self-hosted hash or with labels runs on self-hosted Linux GPU.
Best practices. Run runners in containers or ephemeral vmtks. Avoid persistent state between jobs. Never run self-hosted runners on public repos. Anyone can submit a PR that executes code on your machine. Use auto-scaling, Kubernetes-based runners, WSISGs, to scale with demand. Keep runner software updated for security patches. Apply the principle of least privilege to runner service accounts.
How does caching improve CI/CD performance?
Caching stores frequently downloaded or computed data between pipeline runs, avoiding redundant work that would otherwise happen on every build. What to cache? Package dependencies.
Node modules /m2/ /cache/pip vendor /
Build outputs compiled artifacts. TypeScript build cache, Webpack cache, Docker layers, avoid rebuilding unchanged layers. Test results, reuse results for unchanged code, NX, Bazel. Example, GitHub Actions dependency caching.
Code uses action/cache at v4 with path ~npm node modules key node $runneros $hash files /package-lock-json restore keys node $runneros.
How cache keys work, the
Key
is a unique identifier tied to the lock file hash. If the lock file changes, new dependencies, the cache is rebuilt.
restore keys.
Provide fallback partial matches for warm starts, Docker layer caching.
Code uses docker/build push action at v5 with cache from type equals ga cache to type equals ga mode equals max.
Impact, caching typically reduces pipeline time by 30 to 60%. A Node.js project that takes 3 minutes to
npm install.
can restore from cache in 5 seconds. Caveat, stale caches can cause hard-to-debug issues. Set TTL and invalidate caches when build tools or major dependencies change.
What is parallel execution in CI/CD?
Parallel execution runs multiple pipeline jobs or steps simultaneously instead of sequentially, dramatically reducing total pipeline time. Job-level parallelism, run independent jobs at the same time.
Code hash these 3 jobs run concurrently. Jobs, lint, runs on, Ubuntu latest, steps, run npm run lint, unit tests, runs on, Ubuntu latest, steps. Run npm test, security scan, runs on, Ubuntu latest, steps, run npm audit.
Matrix builds, test across multiple versions, /platforms in parallel.
Code strategy matrix, node 18/2022, OS, Ubuntu latest, macOS latest, runs on, $matrix OS steps, run node version.
Test splitting, distribute a large test suite across multiple runners. Circle CI has built-in test splitting by timing data, Jest supports.
Shard equals 1/3.
To split tests across workers, PyDistXdist runs tests in parallel processes, dependency-aware parallelism.
Code jobs build, hash runs first, test, needs, build hash waits for build, deploy, needs, test hash waits for test, docs. Hash runs in parallel with everything, no needs.
Key insight, a pipeline with 5 sequential stages taking 2 minutes, each equals 10 minutes total. Parallelizing 3 of them could bring it down to 6 minutes.
What is dynamic versus static analysis in CI/CD security?
Static and dynamic analysis are complementary security scanning approaches that catch different types of vulnerabilities at different stages of the pipeline. Static application security testing, SIST, analyzes source code without executing it, finds vulnerabilities in the code itself. Runs early in the pipeline, shift left, often on every PR, catches. SQL injection patterns, hard-coded secrets, insecure crypto, XSS vulnerabilities, buffer overflows. Tools, SonarQuebec, SemGrep, CodeQL, Checkmarks, Bandit, Python. ESLint security plugins, pros. Fast, finds issues before code runs, covers all code paths. Cons, higher false positive rate, can't detect runtime configuration issues. Dynamic application security testing, DIST. Tests the running application by simulating attacks against it. Runs later in the pipeline, typically against a staging environment. Catches, authentication flaws, server misconfigurations, runtime injection vulnerabilities, exposed IPIs. Tools, OWASP ZIP, Burp Suite, Nuclei, Nikto, pros. Finds real exploitable vulnerabilities, low false positive rate. Cons, slower, only tests reachable code paths, needs a running environment, software composition analysis, SCI. A third category, scans your dependencies for known CVEs. Tools, Snike, Dependabot, Trivi, Gripe, catches. Vulnerable libraries, license compliance issues. Best practice, run all 3 in your pipeline, SIST on every PR, SCI on every build, DIST against staging before production deployment.
What is a feature flag, and how does it work in CI/CD?
A feature flag, or feature toggle, is a mechanism to enable or disable features at runtime without deploying new code. It decouples deployment from release. Why feature flags matter for CI/CD? Deploy anytime, release when ready, code can be merged and deployed to production while the feature is hidden behind a flag. Instant rollback, flip a flag off instead of redeploying, progressive rollout, enable for 5% of users, then 25%, then 100%. A /B testing, show different experiences to different user segments, simple implementation.
Code if feature flexible, new checkout flow, user equals current user, return render new checkout, else, return render old checkout.
Feature flag platforms. Launch Darkly, Unleash, Flagsmith, Splitio, a WS app config, CI/CD integration patterns. Deploy with flag off, run smoke tests, enable for internal users, gradual rollout, automatically disable flags if error rates spike, kill switch. Clean up stale flags, remove code paths for flags that have been 100% on for weeks, types of flags, release flags, hide incomplete features, short-lived. Experiment flags, a /B tests and analytics, medium-lived. Ops flags, circuit breakers and kill switches, long-lived. Permission flags, premium features for specific users, permanent. Warning, feature flags add code complexity. Without cleanup, they accumulate as technical debt. Always set expiration dates on temporary flags.
What is observability in CI/CD?
Observability is the ability to understand what's happening inside your CI/CD pipelines and deployed applications by examining their outputs. Logs, metrics, and traces, the three pillars. Logs, detailed event records from pipeline jobs and applications. Pipeline build logs, deployment logs, application error logs. Centralize with ELK Stack, Elasticsearch, Logstash, Kibana, Loki or CloudWatch logs, metrics, numerical measurements over time. Pipeline duration, success/failure rates, queue wait times, application metrics. Request latency, error rates, CPU/memory usage. Tools, Prometheus plus Grafana, Datadog, New Relic. Traces, end-to-end request tracking across services. Follow a request from the load balancer through microservices to the database. Tools, Jaeger, Zipkin, OpenTelemetry, AWS X-Ray. CI/CD specific observability. Track DORA metrics, deployment frequency, lead time, change failure rate, MTTR, monitor pipeline health, which stages fail most, which are slowest. Alert on deployment anomalies, error rate spikes after a deploy signal a bad release. Use deployment markers in monitoring dashboards to correlate metrics with releases. Why it matters. Without observability, CI/CD is deploy and pray. With it, you can detect regressions in minutes, understand root causes faster, and automate rollbacks based on real data.
What is immutable infrastructure?
Immutable infrastructure means servers and environments are never modified after deployment. Instead, they are replaced entirely with new instances built from a versioned image. Mutable traditional approach.
Code deploy v1, SSH in, update packages, modify configs, restart services.
Problem, each server drifts over time. Server A might have different patches than server B. Debugging becomes a nightmare. Immutable approach.
Code build image with v2, deploy new instances, route traffic, destroy old instances.
Every instance is identical because it came from the same image. How it works in practice. Containers, build a new Docker image for each release. Never.
Docker exec.
Into a running container to make changes. VM images. Use Packer to build IMIs/GCE images with the application baked in. Serverless, each deployment is inherently immutable, new function version. Benefits, no configuration drift, Every instance is identical. Reliable rollbacks, just redeploy the previous image, easier debugging. If it works in the image, it works in production, better security, no SSH access needed, smaller attack surface. CI/CD integration. The pipeline builds the immutable artifact, Docker image, IMI, tests it, and deploys it. The artifact is the deployment. There's no separate configuration step. Tools, Docker Packer, Terraform, Kubernetes, AWS ECS, Google Cloud Run.
What are the key metrics for CI/CD performance?
Measuring CI/CD performance helps teams identify bottlenecks and continuously improve their delivery process. The industry standard is the DORA metrics from Google's DevOps Research and Assessment Team. 1. Deployment frequency. How often your team deploys to production. Elite teams deploy on demand multiple times per day. 2. Lead time for changes. Time from code commit to running in production. Elite teams achieve less than 1 hour. 3. Change failure rate. Percentage of deployments that cause a failure in production. Elite teams stay below 5%. 4. Mean time to recovery, MTTR. How long it takes to restore service after a production failure. Elite teams recover in less than 1 hour. Pipeline-specific metrics to track. Pipeline duration, total time from trigger to completion. Target, under 10 minutes for CI, queue time, how long jobs wait for a runner. High queue times mean you need more runners. Flaky test rate, tests that pass/fail randomly. These erode trust in CI, cache hit rate, are your caches actually being used? Build success rate, percentage of pipeline runs that pass. Sustained drops signal systemic issues, how to track, GitHub, built-in actions metrics, GitLab, CI/CD analytics dashboard. External, Sleuth, LinearB, Datadog CI visibility, Prometheus plus custom metrics. These metrics matter because they directly correlate with engineering team performance and business outcomes.
How do you ensure zero downtime deployments?
Zero downtime deployment means users experience no interruption during a release. This requires careful orchestration of traffic, health checks, and deployment strategy. Strategy 1, rolling updates, Kubernetes default. New pods are created before old ones are terminated.
Code spec strategy, type, rolling update, max unavailable, 0# never remove a pod before replacement is ready. Max surge, 1# add 1 new pod at a time, min ready seconds, 10# wait 10s after ready before continuing.
Strategy 2, blue-green deployment, run both versions simultaneously, switch traffic via load balancer or DNS. Instant rollback by switching back. Strategy 3, canary deployment. Gradually shift traffic, 5%, 25%, 50%, 100%, monitoring metrics at each step. Critical requirements for zero downtime, health checks, load balancers must know when new instances are ready.
Code readiness probe, HTTP GET, path/health, port, 8080, initial delay seconds, 5, period seconds, 3.
Graceful shutdown, old instances must finish in-flight requests before terminating. Handle SIGTERM, drain connections. Backward compatible database migrations, the old version and new version must both work with the current schema. Use expand contract migrations, add new column, deploy new code, backfill. Remove old column, session management, don't store sessions in memory. Use Redis or database-backed sessions so requests can be served by any instance.
What is a release train in CI/CD?
A release train is a deployment model where releases ship on a fixed, predictable schedule, whether or not all planned features are ready. How it works. A release cadence is defined, for example, every 2 weeks, every month. Features that are complete and tested by the cutoff date make it onto the train. Features that aren't ready simply wait for the next train. The train departs on schedule regardless, real-world examples. Chrome, new version every 4 weeks. Ubuntu, new release every 6 months, April and October. iOS, major release annually, minor releases on a regular cadence, benefits. Predictability, stakeholders know exactly when features will ship, reduced risk. Smaller, incremental releases are safer than big bang deployments. Less pressure, missing one train isn't catastrophic. The next one is only weeks away. Simplified coordination, QI, docs, marketing can plan around fixed dates, CI/CD integration. A release branch is cut from main at the cutoff date. The pipeline runs full regression testing and security scans on the release branch. Only critical fixes are cherry-picked into the release branch after cutoff. Deployment is automated on the scheduled date. Release trains versus continuous deployment. Release trains work well for products with external dependencies, documentation, marketing, compliance. Continuous deployment is better for internal services, where speed matters more than coordination.
How do you handle database migrations in a CI/CD pipeline?
Database migrations are schema and data changes that must be applied safely, automatically, and in coordination with application deployments. Migration tools by ecosystem. Flyway/Liquibase, Java ecosystem, SQL-based migrations, Django migrations/Alembic, Python, Prisma migrate/Nex, Node.js, active record migrations, Ruby on Rails. Golang migrate Go, CI/CD pipeline stages for migrations. 1. Validate, check migration syntax and compatibility.
Flyway validate.
2. Test, run migrations against a test database, then run application tests. 3. Apply, execute migrations against the target environment. 4. Verify, confirm the schema matches expectations, the expand contract pattern, for zero downtime. This ensures old and new application versions both work during deployment. 1. Expand, add new column/table, old code ignores it. 2. Deploy, new code uses the new column. 3. Migrate data, backfill the new column. 4. Contract, remove the old column after old code is fully replaced. Best practices, migrations must be idempotent, safe to run multiple times. Never put destructive migrations, DROPT, IBLE, DROPC, OLUMN. In the same release as the code change, store migrations in version control alongside application code. Use migration locks to prevent concurrent execution. Always have a tested rollback migration for critical changes. Never put real passwords in migration scripts. Use the example in staging/CI only with test credentials.
What is trunk-based development, and how does it impact CI/CD?
Trunk-based development, TBD, is a source control strategy where all developers commit directly to a single main branch, the trunk. Keeping branches extremely short-lived, hours, not days or weeks. How it works. 1. Developer creates a short-lived branch or commits directly to trunk. 2. Changes are small and merge within hours, not days. 3. CI runs on every push, automated tests must pass before merge. 4. Production deployments happen directly from trunk. Impact on CI/CD, faster pipelines. Small, frequent merges mean smaller diffs to test and review, fewer merge conflicts because branches don't diverge far. Higher CI/CD requirements. The test suite must be fast and reliable. Developers merge many times per day. Feature flags are essential to hide incomplete features behind toggles. Automated quality gates replace long code review cycles. Comparison with Git flow, long-lived branches, develop, release, hotfix. Complex merge process, infrequent releases. Trunk-based, single branch, short-lived feature branches, continuous releases, example workflow.
Code git checkout b feature /add login hash short-lived branch hash. Make changes 1 day of work. Git push and an open PR hash CI runs automatically. Hash PR reviewed, merged within hours. Hash pipeline deploys to staging, production.
Who uses it? Google, Meta, Netflix, and most companies practicing continuous deployment. Google's monorepo has thousands of developers committing to a single trunk.
How do you implement blue-green deployments in Kubernetes?
Blue-green deployment in Kubernetes runs two identical environments, blue equals current, green equals new, and switches traffic between them instantly. Implementation using services. Step 1. Deploy both versions with different labels.
Code #blue deployment current v1, API version, app/v1, kind, deployment metadata, name myappblue spec, replicas 3 selector, match labels, app myapp. Version blue template, metadata, labels, app myapp, version blue spec, containers, name app, image myapp 1.0.0.
Step 2. Service points to blue.
Code API version, v1 kind service metadata, name myapp spec, selector, app myapp version, blue #left arrow traffic goes to blue ports, port 80.
Step 3. Deploy green v2. Test it internally. Step 4. Switch traffic by updating the service selector.
Code kube control patch service myapp /pspec, selector, version, green.
Step 5. If issues arise, switch back instantly.
Code kube control patch service myapp /pspec, selector, version, blue.
Alternative. Use Argo rollouts for automated blue-green with analysis.
Code API version, argoprogio/v1 alpha 1, kind, rollout spec, strategy, blue-green, active service, myapp active, preview service, myapp preview. Auto promotion enabled, false.
Trade-off. Blue-green requires double the infrastructure during deployment, but provides the fastest possible rollback.
What is a service mesh, and how does it help CI/CD?
A service mesh is a dedicated infrastructure layer that manages service-to-service communication in microservices architectures, using sidecar proxies attached to each service. Popular service meshes: Istio, Linkerd, Console Connect, how it helps CI/CD, traffic management for deployments. Canary releases, route 5% of traffic to the new version, monitor, then increase. A /B testing, route traffic based on headers, cookies, or user attributes. Traffic mirroring, send a copy of production traffic to the new version without affecting users. Example, Istio Canary routing.
Code API version, networking istio/v1 beta 1, kind, virtual service spec, hosts, my service, HTTP, route, destination, host, my service. Subset stable weight, 95, destination, host, my service. Subset canary, weight, 5.
Observability, automatic distributed tracing across services, no code changes. Request level metrics, latency, error rates, throughput per service. Enables metric-based automated rollbacks in CI/CD, security, mutual TLS, between all services, encrypted communication by default. Authorization policies, control which services can talk to which. Zero trust networking, services must authenticate even within the cluster. CI/CD benefit. The service mesh gives you fine-grained control over how traffic reaches new deployments, enabling safer, more gradual releases without modifying application code.
What is progressive delivery in CI/CD?
Progressive delivery is an evolution of continuous delivery that adds fine-grained control over how features are exposed to users. Instead of deploying to everyone at once, changes are released incrementally with automated safeguards. Progressive delivery techniques. 1. Feature flags. Toggle features on /off without deployment. Enable for internal users first, then beta users, then everyone. 2. Canary releases. Deploy to a small percentage of infrastructure, monitor metrics, and gradually expand. 3. A /B testing. Deploy different versions to different user segments to measure impact on business metrics. 4. Dark launches. Deploy new code to production but don't expose it to users. Use traffic mirroring to test with real data. 5. Ring-based deployments. Deploy in concentric rings, internal, beta, 10%, 50%, 100%. Microsoft uses this for Windows updates, tools that enable progressive delivery. Argo rollouts, Kubernetes native progressive delivery with automated analysis. Flagger, progressive delivery operator for Kubernetes, works with Istio, Linkerd. Launch Darkly/Unleash, feature flag management, Splitio, feature delivery with experimentation. Key principle: every stage has automated analysis, error rates, latency, business metrics. That determines whether to proceed, pause, or roll back. This replaces the binary, deploy, or don't deploy with a spectrum of gradual exposure. Progressive delivery gives teams the confidence to deploy more frequently because the blast radius of any single change is limited.
How do you handle long-running tests in CI/CD pipelines?
Long-running tests, integration, E2E performance, can bottleneck your entire pipeline. The goal is to get fast feedback without sacrificing test coverage. Strategy 1. Test pyramid and pipeline stages. Structure your pipeline so fast tests run first and block early.
Code unit tests seconds. Fail fast integration tests min. Run in parallel E2E tests 5 to 15 min. Run only on main branch or before deploy. Performance tests long. Run nightly or on schedule.
Strategy 2. Parallel test execution. Split tests across multiple runners.
Code #jest sharding strategy matrix. Shard 1 2 3 4 steps. Run npx jest shard equals $matrix shard/4.
Strategy 3. Test impact analysis. Only run tests affected by the code change. NX.
NX affected target equals test.
Bazel automatically determines affected test targets. Jest.
Changed since equals main.
Strategy 4. Mock external dependencies. Replace slow external calls with mocks. Wire mock/mock server for HTTP services. Test containers for databases faster than shared test databases. Local stack for AWS services. Strategy 5. Shift expensive tests right. Run heavy tests after merge on a schedule, rather than blocking every PR.
Code on schedule. cron 03*# nightly at 3 a.m.
Target PR feedback should come in under 10 minutes. Move anything slower to post-merge or nightly pipelines.
What is chaos engineering, and how does it fit into CI/CD?
Chaos engineering is the practice of intentionally injecting failures into systems to verify they can withstand real-world disruptions. It answers, will our system survive when things go wrong? Core principles from Netflix. 1. Define a steady state based on measurable system behavior. 2. Hypothesize that steady state will continue under stress. 3. Inject real-world events. Server crashes, network latency, disk full, dependency failures. 4. Look for differences between steady state and observed behavior. Common chaos experiments. Kill random pods/containers, inject network latency between services, simulate cloud provider outages, IZ failures. Fill disk to capacity, spike CPU/memory usage, tools. Litmus Chaos, Kubernetes native chaos engineering, Chaos Monkey, Netflix. Randomly terminates instances, Gremlin, Enterprise Chaos Platform. AWS Fault Injection Simulator, managed chaos for AWS, integrating into CI/CD.
Code stages build, test, deploy staging. Chaos test # left arrow chaos experiments in staging, deploy production.
Example pipeline step.
Code name run chaos experiment run litmus run pod delete \, namespace equals staging \, duration equals 60s, # verify application remained available. Curl fail http / staging example com/health.
Important, start with chaos experiments in staging, not production. Graduate to production only when you've built confidence and have proper observability.
How do you implement immutable deployments in CI/CD?
Immutable deployments mean never modifying running infrastructure. Instead, every release creates new instances from a versioned, tested artifact, the immutable deployment flow.
Code change, build artifact, test artifact, deploy new instances, switch traffic, destroy old instances.
Container-based, most common.
Code #CI pipeline builds an immutable image, steps, run, docker build tmyapp, $GitHub SHA, run, docker push registry example com/myapp, $GitHub SHA. Hash deployment uses the exact image, run, the cube control set image deployment /myapp / your app equals registry example com/myapp, $GitHub SHA.
VM-based, using Packer.
Code #build an IMI with the application baked in, Packer build var version equals 1.2.3, app pkrhcl. Terraform deploys new instances from the IMI. Terraform apply var AMI ID equals AMI ABC 123.
Anti-patterns to avoid.
As late.
Into a running server to make changes.
Docker exec.
Into a container to patch files, applying hotfixes directly to production instances. Using.
apt-get upgrades.
On running servers, best practices. Tag every artifact with the commit SHA or version number, never reuse tags.
myapp latest.
In production is dangerous. Build once, deploy many, the same image goes through dev. Staging, production. Store all configuration as environment variables or external config, not baked into the image. Maintain a rollback path. Keep previous images in the registry. The combination of immutable artifacts plus infrastructure as code plus CI/CD automation gives you fully reproducible, auditable deployments.
What are the best practices for securing CI/CD pipelines?
CI/CD pipelines are a prime attack vector. They have access to source code, production credentials, and deployment infrastructure. A compromised pipeline can deploy malicious code directly to production. 1. Secure secrets. Use external secret managers, Vault, a WS secrets manager. Over platform-native secrets when possible. Never store secrets in code, environment files, or pipeline configs committed to Git. Use OIDC Federation for cloud access. No static credentials to steal. Rotate secrets automatically and audit access logs. 2. Lockdown access. Require MFI for CI/CD platform accounts. Implement RBAC. Developers can deploy to staging. Only release engineers can deploy to production. Require PR approvals and passing checks before merging to protected branches. Use environment protection rules with required reviewers for production deployments. 3. Secure the supply chain. Pin actions/plugin versions to commit SHIs, not tags.
Uses action/checkout at ABC 123.
Not.
At V4.
Run dependency scanning, snike dependabot trivy. On every build, run SIST semgrep code QL and DIST OWASP ZIP. In the pipeline. Sign artifacts and verify signatures before deployment, sigstore/cosign. 4. Harden the build environment, use ephemeral runners, no persistent state between builds. Run builds with minimal permissions, least privilege. Use read-only file systems where possible, never run self-hosted runners on public repositories. 5. Monitor and audit. Log all pipeline executions, configuration changes, and deployments. Alert on anomalies. Unusual deployment times, unauthorized access, configuration changes. Implement SALSA, supply chain levels for software artifacts. For build provenance, regularly audit who has access to what. 6. Network security. Isolate CI/CD runners in dedicated network segments. Use private endpoints for artifact registries and secret managers. Restrict outbound network access from build environments to only necessary destinations. Security isn't a single stage in the pipeline, it's a concern woven into every stage.